Good evening, JEE enthusiasts. After drifting to the uniform circular motion, let's move ahead and let's go around the corners by bending. So we have drifted in the previous session. Now let's bend a little along those nice curves and let's see, why do we need to bend? What is the reason why you have to tilt your bike when you are going around a corner? Why are the roads tilted towards the end? A lot of you might think you know the answer, but trust me, I'm going to change your perspective today by the end of the class. There's a very interesting reason. You think you know it, but trust me, it's going to be a little bit interesting. Alright? So this is me, Shreyas, your master teacher for physics at Vedantu, going live. And welcome aboard all the JEE enthusiasts to this very special session of non-uniform circular motion. And I'm going to complete the entire part of non-uniform circular motion today. In every one session of Flash, we try to cover one major topic. We try to do problems on those major topics, and that is the whole point of Flash series. So all the students of 11th standard, 12th standard, and even the droppers probably who have not started their preparation, or maybe they did not get good kind of coaching in the last few months, do not worry guys, we are going to make sure that you excel, you learn everything in this small amount of time that you have till the month of February or March. Alright, so much before that we are going to complete the entire thing, right, in different ways. So stay tuned. And this is Shreyas here. I've been teaching for the past 11 years. Like you all know, I have produced many great results and I intend to do the same thing with you. So welcome aboard Akhila, Ryan, Ankit, Kirito, Sanspriya, and so many others out here. Hello Kashyap. Welcome aboard. Hello Palak. Hello Uncharted. Hello Aarti. So many regular students and so many new joiners also today. So let's make this family big, and do not forget to like the video, because remember guys, without your likes I won't get energy. So you have to like the video so that I get the energy and I keep posting such amazing stuff. And all the new timers out there, do not forget to subscribe, because if you do not subscribe, then what will happen? You will not get notified. So you have to subscribe and like, or else YouTube won't recommend you our videos, alright? Or else you will miss out on the amazing stuff that we do out here. Now I have a very important announcement to make. Do you know what important announcement it is? Well, it's about tomorrow. Very good, Ratan. I know you two are regular. Kya baat hai? VSG, very good. Hello, Anuradha. Hi, Dinesh. Oh, you like my hairstyle, Dinesh. Thank you. I tried something new out today. Thank you, Akhila. Thank you. Suspense, yes. Hi, G. Rameshwar. Any idea on what the surprise is? So let me break the surprise. Guys, what is tomorrow? Any idea? Guess what is tomorrow? Thank you, Krito. So sweet of you, yaar. Acha, what is tomorrow, guys? Come on. Let's play around. What is tomorrow? Yeah, tomorrow is Tuesday, but something else is there tomorrow. What else is there? No, Diwali is next week. No, Bollywood session to happened in previous week. No, it's not my birthday. What else is there in the night? Come on, think about it. What is there in the night? What is there in the night? No, it's not Children's Day. Children's Day is on 14th. Tomorrow is something else. Yes, Hari got it. Hari got it. Yes, it's the IPL. So, guys, 7:30 p.m. is Mumbai versus Delhi match, correct? So, what are we going to do at JEE Enthusiasts? Yes, what are we going to do? I know you guys are very eager to watch that match as well. So, I have planned an amazing session tomorrow at 6:30. Yes, Wazim sir is going to end his lecture a little bit early, and I'm going to start my session at 6:30. But it is not a regular session, let me tell you that. It's a special session, and just like I conducted Bollywood and physics, this is going to be cricket and physics. So cricket and physics with me, Shreyas, your master teacher, tomorrow at 6:30 p.m. It's an incredible session, and I'll tell you one more news. Tomorrow there will be no derivations or formulas, problem solving. It's just pure physics. Not too much maths, nothing like that, no calculations tomorrow. It's just basic formulas or just enjoying tomorrow is our main motive. So are you guys eager and are you guys enthused about it? What say, guys? What say? Are you not eager? What say? Come on, let me know in the chat box. I'm reading it. Very good. So do not forget to spread the word. Let's spread this across to as many people as possible that tomorrow, just like the Bollywood session I conducted on Biotonic channel, tomorrow I'm going to conduct at 6:30 p.m. cricket and physics. Yes, how do I relate cricket and physics? And believe me, you might just think, oh, it's just going to be projectile motion. Nah, it's not just going to be projectile motion. You will see how deep I'm going to go and you're going to have fun. All right. So that's what we're going to see tomorrow. And now let's begin with our session today. Very good. So you have to comment in the chat box, not here in the live chat box, after the session ends. Whom are you supporting? Are you supporting Mumbai or are you supporting Delhi, or maybe you just don't like watching IPL? So comment after the session ends. I'll be reading all your comments after the session ends, because now whatever you comment will just go in the live feed. So after the session ends, all right? So let me know out there. Amazing, amazing. No, Kirito, it's not going to be just kinematics. That's what you think it is going to be, but it is not just going to be kinematics. You will see what it is tomorrow. It's not just kinematics. Kinematics is hardly, maybe, I don't know, hardly one slide or two slides. Okay, chalo. So last lecture, in the last session, we have seen what a uniform circular motion looks like. Uniform circular motion is where omega, or the speed, remains constant but the direction keeps changing. That's what we have seen. So what is the angular wise acceleration? 0, because it covers same angle in the same time. So angular velocity is constant, so angular acceleration is 0. That's what we saw. Now what if there is some angular acceleration? And that's what we are going to see. So last session I have told you what angular acceleration is all about. So alpha is d omega by dt, and it is expressed in radians per second. So say for example, if omega changes from 2 radians per second to, let's say, 5 radians per second in 0.5 seconds, then alpha is the change in the angular velocity, which is 5 minus 2, upon the time taken, which is just 0.5. So 5 minus 2, guys, is 3, and this is by 2, so that will become 6 radians per second square. So that is the angular acceleration of that particle. All right. So now that we are talking about non-uniform circular motion, understand alpha will not be 0, omega will not be constant, it can vary. And I have also mentioned one more thing, that if you have a graph of omega versus time, and if that graph is something like this, and let's say you happen to draw a tangent somewhere at some point, then the slope of that tangent is also alpha. Understand that. So slope of the tangent drawn to the omega versus time graph is also the angular acceleration. All right, so that's something what we have seen. So what if angular acceleration is not 0 is what we are going to see today, just like I mentioned. So let's think about first a term called as tangential acceleration. Now in the previous session, I hope you remember, we have studied something called as the centripetal acceleration. So if a particle is going in a circular path with some speed v, then it has some acceleration towards the center, and this v is nothing but constant. All right, so this is in case of uniform circular motion. That's how it was. This was the centripetal acceleration. But if this speed is not constant, then understand this centripetal acceleration will be different. I mean, it will change because speed is changing. I hope you remember AC was v square by r. So as the speed changes, even the centripetal acceleration will change. But apart from that, there will be one more acceleration called as the tangential acceleration. Yeah, so that is the tangential acceleration, which is along the tangent to the path, which causes the speed to change. So that is what is tangential acceleration. Now observe this diagram. It's kind of self-explanatory. So there is a particle which goes in a circular path, all right, and you will see that the speeds at different points are different. Why is the speed different? Because there is tangential acceleration. So remember one very important trick. It's not just for circular motion, but in general trick this is. What is that in general trick? If you have any kind of acceleration, okay, this is any kind of acceleration, and let's say this is your velocity. Say for example, this is the velocity, okay. If acceleration and velocity are not in the same direction, they make some angle, then you can always split that acceleration, guys, into two parts. Yes, you can split the acceleration into two parts, one along the velocity and one which is perpendicular to the velocity. The one which is along the velocity is called the tangential acceleration. The one which is perpendicular to the velocity is called centripetal acceleration. So that's how it works. So understand, whenever I have a particle going in a curved path, alright, so there will be two kinds of accelerations. If speed is not constant, assuming it is varying, so assume that the speed is varying, so there is going to be something called as the tangential acceleration as well as the centripetal acceleration. What is the total acceleration? Well, it will be the vector sum of both of them. That will be the total acceleration, and each acceleration has its own role or own job. What is the job? Think about it. Centripetal is only responsible for changing the direction. So it only changes the direction of the velocity, nothing else. It does not change the speed. Who changes the speed? Remember, I just introduced tangential acceleration because the speed was varying. So this tangential is responsible for changing the speed. So when you are going on a curved path, alright, or a circular path, if your speed is increasing, it is increasing or decreasing, let's say, then the speed change is only because of the tangential acceleration. The direction change is happening because of the centripetal acceleration, and together, combined together, that is the total acceleration. I hope this is clear, guys. I hope this is clear. Very good, very good. Okay, so very important pointers. I hope you guys you are making notes, because if you don't make notes, you'll forget all these things, and that is the whole essence of this flash series, that you have to keep making notes. Only then it will enter your head. And remember, I'm going to also conduct some problems after this concept explanation. All right, so keep all these things in mind. Now, if you have understood till here, is there any relationship between tangential acceleration and angular acceleration? Yes, there is, and let me tell you what it is. Okay, so what is the relationship between tangential and angular acceleration? Here it comes. Remember, in the previous session I have already told you V is R into omega. I have told you about this velocity and omega are related to each other. Alright, now imagine if I differentiate this. Derivative of velocity with respect to time will be, think about it, d by dt of r omega. But that r can come outside because it is a constant, and what will remain? D omega by dt. Now I just told you what d omega by dt is. It is nothing but angular acceleration. So understand, this is alpha, which is angular acceleration, and this is dv by dt. What is this dv by dt? dv is not change in velocity, it is just change in the speed. Yes, over here. So it is basically rate of change of speed, and this is nothing but tangential acceleration. Remember, I just told you some time back, tangential acceleration only changes the speed, correct? So that's why rate of change of speed is called tangential acceleration, and the rate at which direction changes, you can think of it, that is centripetal. So centripetal is only responsible for the direction change. Tangential is only responsible for the speed change. If you remember this, you are sorted for circular motion. Okay, so keep this in mind. So this is again a very important relationship. Think about it. If alpha is 0, think about it. If alpha is 0, what will happen? If alpha is 0, then it implies omega is constant. That also tells me it is uniform circular motion. And it also tells me A tangential is 0, and if A tangential is 0, V tangential is nothing but a constant. That is what happens in uniform circular motion. Okay, so having said this, if everything is clear, give a thumbs up, Say yo, say yes, say I, or something like that. Okay, is that clear, everyone? Can we go ahead? Very good, very good. Somebody is also putting a party symbol. Very good, guys. Okay, so that was tangential acceleration. Now think about it. In my previous session, didn't I tell you, if a particle is having acceleration, it will also need a force to accelerate it. Same way, if a particle has tangential acceleration, which is changing its speed, there must be some force responsible for the tangential acceleration. So here is the logic behind it. Imagine a particle is going in a curved path with some speed, which is again varying, obviously, because it is non-uniform circular motion that we are talking about, and at some instant it has some tangential acceleration and it also has some centripetal acceleration. If there is centripetal acceleration, there must be a force, like I have told you before, a centripetal force giving this centripetal acceleration. I have told you about this. Fc is equal to m into AC, correct? And I have also told you the value of AC is nothing but v square by r. That's what I have told you. Now, if there is tangential acceleration, what should be there? There must be a force producing this tangential acceleration, that is called as tangential force. And just like before, you can apply Newton's law and you can very well say tangential force is mass into tangential acceleration. That is very well valid. There is no doubt about it. So is tangential force a new kind of force like gravity, spring, electrostatic? What do you guys think? Is it a new kind of force? Is centripetal a new kind of force? What did I tell you last session? No, it is not. It's just a name given to a force. So there could be many forces acting on it. All those forces in this direction are called tangential forces. All those forces in this direction are called as centripetal force. They are just the components of those forces, understand? So it's not a new force that you will show. And you will see it when I show you some diagrams, then these concepts will become more and more clear. But just for now, keep it in your head that tangential and centripetal are not new kinds of forces. Alright? Okay, very good. So if anything is constant, no, Saurabh, if let's say it is going with v constant speed, then velocity is not constant because velocity is a vector, the direction is changing. Understand that. Alright. So if somebody asks you what is the total force, what will you do? Vector addition. So centripetal is here, tangential is there, the resultant will be here. So understand, F or the net force will be root of Fc square plus Ft square. So that is the net force which will be in somewhat in this direction. Okay, so that will be the net force. Okay, so keep all these things in your notes. Very, very important stuff, guys. You have to keep all this stuff in your notes or else you will forget it. Alright, so that was it about tangential acceleration. And like I have told you before, also keep these things in your mind. If this is the acceleration, this is tangential. If this is centripetal, this acceleration again is AC square plus AT square, and tangential is the one which is in the direction of velocity. Remember that. Again, centripetal is responsible for direction change. This is responsible for speed change. AC is V square by R or omega square R, okay, and A tangential is nothing but alpha R, or you can also use just dV by dt. So the rate of change of tangential velocity is nothing but the tangential acceleration. So these are some important formulas which you should keep in mind. I'm giving you all the formulas, guys. So all the droppers, all the 12th standard students, very useful for you for quick revision, and all the 11th standard students who have probably missed all these points, again very important for all of you to remember all these formulas. Very, very important slide. Everything is important. Everything is important, Saurav. You cannot say this is important, this is not important. Everything is important. Whatever I write on the board is important. Alright? So, okay. Yes, it's the component. It's the component. Tangential and centripetal are the components. Alright. So don't worry, we are going to go to problems and then you'll get some idea out of this. Alright. So let's do a problem on a centrifuge. Okay, so where an astronaut who is supposed to be trained to experience, or a fighter pilot who is supposed to be trained for extreme forces, they are rotated at very high speeds and they experience immense amount of G-force which they have to tolerate. So if they do not pass this test, they cannot become a pilot or an astronaut. So it's crazy. They experience 5 to 6 times, sometimes more than the actual weight that they have. So it's very, very interesting. Very good, Ryan. So you have to pass this test. Okay. Chalo. Let's get going then. Let's see how to solve this problem. Come on, guys. An astronaut is being tested in a centrifuge. The centrifuge has a radius of 10 meters. And it is starting from rest, let's say, and rotates according to this equation. Theta is 3t square. So theta is a function of time, where t is in seconds and theta is in radians. When time is 5 seconds, what is the magnitude of the astronaut's angular velocity, linear velocity, tangential acceleration, radial or centripetal acceleration? Okay, it's actually the same thing. This should have been centripetal force, okay, not centripetal acceleration, and one should be tangential force. So I'll just correct it in the next slide. But we have to find basically pura khandan. We have to find every bit of it. Uska pura, we have to just figure out every bit of that khandan. Alright, so let's see how do we do this. So I'll just rephrase this part. So centripetal force is done. So here we need to find tangential force. Okay, so that's what we need to find. So let's get going without wasting more time. Now, theta is given as a function of time. From that, what and all can we find? Let's figure it out. So if theta is given to be 3t square, I can find omega. Omega is derivative of theta. So think about it. What will be the derivative of 3t square? What will be the derivative? 3 into 2t. So that is basically 6t. So that is omega. Now I can also find alpha, guys. Alpha is d omega by dt. So derivative of 6t will be just 6. The good thing is alpha is a constant. So I'll just put it as radians per second square. If this was a cubic function, this would be a quadratic function, this would be a linear function. So that case, alpha won't be constant. So now this is in radians per second and this was in radians. Okay, so we have to find when everything is t is equal to 5 seconds. So let's put time as 5 and let's see what do we get. Okay, so what is the astronaut's angular velocity at 5 seconds? Omega 5. Just put time as 5. You will get it as 30 radians per second. Alpha at 5 will be constant. So I'll just put it as 6 radians per second square because alpha is constant. That's what is given. Then next thing is linear velocity. Okay, linear velocity at 5 seconds will be omega into r. So what is omega? It was 30. And what is the radius? Look at that. Where is the radius? Yes, 10 meters. So radius is 10 meters. So it will become 300 meters per second. That's the velocity at 5 seconds. Okay, so we have found out part A, angular velocity. We have found out linear velocity. Well, the only thing left is tangential acceleration. So let's figure that out as well. Tangential acceleration is alpha into r. So what is alpha at that point? Well, it is 6. What is radius? It's 10. So 6 into 10, 60. No, this is not radians per second. This is acceleration. This is normal linear acceleration. So this will be just 60 meters per second square. So that is tangential acceleration. Okay, great. We have done this also. So I'll just mark whatever we have found out. This was one thing. This was another thing. This was next. And this is also found. Okay. Now, we have to find centripetal acceleration as well. So let's figure that out. Centripetal acceleration is the velocity at that point divided by square of that by radius. So what is the velocity at that point? I just figured it out. It was 300. So it will be 300 square by 10. So 3 square is 9, 100 square is 10,000, 10,000 by 10 is 1000. So it will become 9,000 meters per second square. Guys, this is crazy acceleration, guys. What do you think? Look at that acceleration. Do you see that? Do you see that? It's 300 square, guys. Velocity was 300 meters per second. It's some crazy amount of acceleration that is happening after 5 seconds. Do you think he will live? Do you think he will live? This is almost, guys, 1000 times more than the actual gravity. I don't think he will live just after 5 seconds. So if you have constant acceleration and after 5 seconds, I don't think he'll just crumble. He will be crushed. Yeah, gone. All right. So the next thing, let's assume the astronaut's mass to be normal, 60, or let's say maybe he's just light. He's maintained and trimmed his body and kept it at 50 kg. Now, the last part, what is the tangential force? So tangential force will be mass into tangential acceleration. What is the mass? I just told you it is 50. What is the acceleration? Well, that is 60 tangential acceleration. 6 5s are 30, and put all these zeros. That is crazy. Tangential force is 3000 Newton, guys. It is crazy, insane amount of force. And centripetal force, look at that. Centripetal force will be mass into centripetal acceleration. What is the mass? 50. What is the acceleration? Oh my god, 9000. Come on, guys, do this. 45, 1, 1, 2, and that's okay. It's 45. Oh, my bad. It's 4,50,000. So this was 50, and this will be 4 lakh. Yes, 4,50,000 newtons. Yes, Akila, for sure he will get crushed. Yes, Manoj, in space there is no weight, but they need to be trained to go to space because the rocket will turn, it will experience immense thrust power. So that's why they need to be trained. And sometimes it can go out of control, so they need to survive those crash landings. So for that they are trained. Yes, Ryan is ready to take up any challenge. Very good, Ryan. Yes, okay, completely muscle tearing, Dinesh, I agree. Yes, Zoom now. It's like, oh my god types, right? So guys, that is the importance of mathematics. It gives you the actual numbers, and it will make you believe whatever you are thinking, if it is correct or wrong. When you get these numbers, it's so interesting to imagine what is going to happen. Without just these numbers, it would be boring because you will not understand the true importance or the value or the significance of these things that are being discussed. All right, so let's go ahead. Yeah, it's a risky job. Before I go ahead, let me also remind you the Diwali offer and the students who are going to be benefited from this Diwali and this Children's Day offer. Guys, Vedantu Pro subscription, which is like Amazon Prime or Netflix subscription, is now at an all-time high discount of 50%. And like you were all asking, what is there in Vedantu Pro? Well, you have your regular crash courses, you have your micro courses, KVPY exam courses, then HC Verma discussion courses, booklet discussion courses, test preparation, assignments, and personal teachers, and a choice of other teachers as well for different courses, and an option to learn in Hindi and English. So that's what you get in Vedantu Pro, and these are just some of the features that I'm talking about. Actually, if you open up the link which is there in the description, you will get all your questions answered. There are these demo classes, etc. Everything you can just experience how it is. Plus, just like over here, you are chatting, you are allowed to chat in our regular classes. Plus, you get a personal teacher for a group of students who answer all your doubts. Yes, they are called as class teachers who answer all your doubts in the live session. So your teacher is teaching, plus there is a teacher who is also assisting you with all your doubts. So that's the beauty of these classes, guys. And right now they are at an all-time high discount of 50%. So you can see the prices. I'll just move away from the screen. All the dropper students, check it out. The price is 228 rupees per day if you take it for 6 months. Yes, till your JEE Advanced is over, we are going to be there with you. So the dropper students should use this 6 months offer. That's what I feel. 50% discount. All right. Then the 12th standard students, again, till your JEE Advanced exam is over, almost 6 more months, you get it for 161 rupees per day. Very affordable again. And the 11th standard students, you have an option of 6 months, 12 months, 1 month, up to you. So I would prefer at least you go for 6 to 12 months because you get a good price, good discount, and plus you don't have to worry about subscribing again. And if you subscribe again, the offer might not be valid, so you will have to pay a higher price. So keep that in mind. All right. So the 12-month offer price is 89 rupees per day. And how do you get this offer? Just use this coupon code SHHPRO. Link is in the description. Yeah, you can check out the details properly, and do not forget to use it before 11th of November. That's hardly few days from now. So do not forget to use this, or else this offer is going to go back. And you all know, just few days back the offer was 20%. It's going to go back to a very small value of discount. So keep that in mind. So use this opportunity to log in into our Vedantu Pro subscription courses. All right, great. Yes, you can get it for 1 month also. NVD, I have posted it on the slides. 1 month, 3 months, 6 months, every offer is valid. Yes. Thank you, Saurabh. Thank you, Saurabh. No, tangential and centrifugal, Satyam, are not equal. Centrifugal acts radially outwards, tangential acts along the tangent. And centrifugal is in a non-inertial frame. Tangential is just a normal force, understand? Okay, very good. Chalo, let's go ahead. And Pandu is back, and Pandu is asking us, what about non-uniform vertical circular motion? A lot of people have problems in this. I have some crazy situations which I'm going to show it to you, and you'll be really amazed to see all this. So let's talk about vertical circular motion, which is non-uniform. Now, why is vertical circular motion non-uniform? Any guesses? Why the word non-uniform has been used in vertical circular motion? Can you guess? Can you guess? Yes, Saurabh, the dot product of tangential and centrifugal will be 0. Pendulum, yes. Gravity, very good. Gravity is there. If somebody swing the pendulum, imagine an astronaut. Where is our astronaut gone? Aryan, yeah. So if Aryan becomes an astronaut and he swings the pendulum, it will be going with constant speed in space. Yes, the speed would be constant. But on Earth, Bichara, the speed won't be constant. It will accelerate, decelerate, accelerate, decelerate. It will accelerate and decelerate because of gravity. Okay, so that's what is going to happen. Ryan, oh, not Aryan, Ryan. Okay, nice name. All right. So pendulum made of thread or a rod. So these are the two kinds of questions that usually come: thread and rod pendulums, which are swinging in vertical circular motion. So understand the difference, guys. When a pendulum swings, draw the free body diagrams. Like mass will have its own weight, there will be tension over here, and depending on where it is, etc., and how it is moving, it can have some angular velocity and all those things. So it might have omega, so it might even have velocity. Okay, and obviously this velocity will be omega into r, but here that r will be the length of the string over here, or the length of that rod, and this will be perpendicular, of course, and it can make some angle over here. Okay, maybe that is theta, something like that. And do not forget, there will be also a tangential acceleration, and there will be also centripetal acceleration, which will be again perpendicular to each other. So all these things will be there, guys, and you have to make equations based on this. For example, if you go along the radial direction, how will your equation look like? And if you go along the tangential direction, how will your equation look like? So first let's talk about radial direction. In the radial direction, what is the tension? mg is component, that's all. There is nothing over here. Okay, don't worry about tangential part, only worry about the radial part. So whatever is there, so that is just tension, and mg's component cos theta. So this is the net force. And why did I do tension minus something, and why not mg cos minus something? understand the acceleration is here, so anything in this direction which supports the acceleration should be taken positive, and anything which opposes it should be taken as negative. So T minus mg cos theta will be m into AC, and now you can substitute AC as v square by L, because that's the centripetal acceleration. So therefore T minus mg cos theta will be mv square by L. That's how your equation will look like in the radial direction. Similarly, in the tangential direction, I think only mg's sine theta is there. So mg sine theta will be m into AT. That's all. That's how your equations will look like. Okay. Now if I ask you, what is the centripetal force in this situation? It is not shown separately. In fact, these two together are called as the centripetal force. These two together. And if I ask you what is the tangential force, it is this one. This one is called as the tangential force. So tangential force is mass into acceleration, centripetal force is mass into again acceleration. I hope this is clear how to look at non-uniform vertical circular problems. Now we're going to take some examples. Alright? Yes, theta is the angle made by the thread. Yes. Okay. Very good, Aarti, Jumna, Royan, Poetry, VSG, excellent. Let's start solving some problems. Now, look at this pendulum. Don't get hypnotized. Don't get hypnotized. So, can you guess what is the maximum angle made by the pendulum with the vertical? With the vertical, what is the maximum angle made by the pendulum? 180, wrong. 90, yes. Yes, it's 90. Very good, Uncharted. Very good, MD, Prashant. Yes, Science Priya, think again, it's not 180. Manoj, it's not 180, it's 90. With the vertical, it makes maximum 90 here and maximum 90 here. So, total is 180, but with the vertical, it is 90 degrees. Now, I want to know with what speed should I hit the ball so that it reaches till here. Okay, with what speed should I hit it at the bottom so that it just becomes horizontal? That's my next question. A sphere suspended by a thread of length L, what minimum speed should you give at the bottom so that it reaches the height of suspension? That is what the question is. So let's try this out. Let's try this out. So if that ball is going like this along this path, all right, and this is obviously 90 degrees. So can I conserve energy if I have given it some velocity over here, let's say u? Can I conserve energy till the time it goes here? Obviously yes. Why? No friction, no bad forces, so I can do that. But there is one problem. There is tension over here, and tension is a bad force. It's a non-conservative force. So remember, you can conserve energy only when non-conservative forces are not doing work. So even if tension is there, you don't have to worry. Remember that example I had given you? Remember that scorpion and all that snake, frog and all those examples I had given you? So even if a bad force is there, but if it is not doing work, don't worry about it. You can definitely conserve energy. Alright, so air resistance is absent and all that. So that's why we can conserve mechanical energy. And remember, to conserve mechanical energy, we always need to assume some reference line. I'll assume this line as zero potential energy. Okay, so any object placed on this line has zero potential energy. So initial potential plus initial kinetic should be final potential plus final kinetic. Now, since the question says the minimum horizontal velocity, that means it just has to reach here. So when it just reaches here, what would be the velocity? Obviously the velocity will be 0. Anything more than this, it will obviously go beyond this point. Alright? And do you think in this motion, the string has a chance of becoming slack? The tension becomes 0. Do you think, is there any chance of that happening in this part? What do you guys say? Can tension become 0 in this path when the pendulum is going like this? till this point only, not beyond this, only till this point. No, very good. So we don't have to worry about the string becoming slack. That's the best part. And now just solve the problem. Initial energy potential wise 0. Kinetic energy is half mu square. What is the potential energy, guys, over here? Think about it. What is the potential energy? How high did it go? Don't worry about this displacement. Just think how much is the difference in the height. I believe it's only the length of the string. So it is mgl. And what is the final kinetic energy? 0. So mm goes and you will get u square by 2 is equal to gl. Therefore, u is equal to root 2 gl. That's the answer. I hope this is fine. Check it out. Alright. So kinetic energy got converted into potential energy, and surprisingly it's independent of the mass of the ball. Very interesting. Most of the times you have seen mass is worthless, it's useless, it always gets cancelled out. Very poor fellow, I mean, always gets thrown away. Nobody cares about the mass most of the times. Alright, so that's how you solve that problem. Now the next part of the problem is, what if you want it to go around the entire circle like this? If you do not give it enough speed, it probably will just fall short of the topmost point and it will come back. Okay, so you have to give it very Saurabh, what do you mean by same formula in two cases? Yes, so just imagine you have to give it some speed and so that it reaches the topmost point and then comes down. So let's look at that part of the problem. Now a lot of people face difficulty in this. A block at the end of the string is whirled around like this in a vertical circle of some radius r. What is the critical speed of the block at the bottom so that it completes the circular motion? That's the question. So first of all, understand, if I have to give it some speed over here, u, and it has to complete the vertical circular motion, what do you think is the necessary condition? Do you think the speed should be 0 at the topmost point so that once it reaches here, it's able to cross through the other point, or is it something else? What do you think is more important? Read the question carefully. What is it attached to? It is attached to a string. When it is attached to a string, there comes a chance that the string might become slack. Yes, the string might become slack. No sort of velocity will be 0 will be the condition when it is a rod and not a string. If string was not mentioned, it was a rod, then understand, when I whirl it around, a string can never bend, correct? It will never crumble. It will never become slack. So even if it has 0 velocity at the topmost point, almost anything more than 0, it will go to the other side. But a string will not do the same thing. Why? The block has a mass. So even before that, the string will just crumble, it will become slack, and it will just do a free fall motion. So it is important that, see, understand what is more important. Velocity should be more than 0, yes, but that is not sufficient. The tension should be more than 0 is the more important condition. I hope this is clear. Yes, I hope this is clear. Okay, now let's try this out. Over here, clearly the speed won't be 0, it will be something, but how much should that speed be? Let's try this out. Okay, so I'm just showing that mass m, but that is at the topmost point. Here is what it will experience. One will be its own weight mg. Second thing, it will experience tension, and I'm sitting on the ground and observing it. So yes, it will have centripetal acceleration. That's it. These are the only forces acting on it. Nothing apart from this is acting. Only if you sit in a rotating frame like this, then there will be a pseudo force, but then this acceleration won't be there. So I am sitting in a ground frame and observing the circular path. So that's the reason why I'm showing it accelerate downwards. So how my equation will look? Tension plus mg will be m into AC. So what is AC? It is nothing but v square by r, because I think the length of the string is given to be r. Okay, now once I get this, just think about what is the value of tension? So tension will be mv square by r minus mg. Okay, interesting thing. Observe this. Observe this carefully now. If I increase the speed, okay, if I increase the speed, then tension will also increase. But if I decrease the speed, tension will decrease. And if I decrease the speed beyond a particular point, tension will become negative. But keep in mind, tension can never be negative because a string can only understand pull. It can never push as such. It will become slack. It's not a rod. So tension has to be at least positive. It always pulls. It can never push something. Understand, you cannot take a rope and push an object. You can only pull an object. So tension can't be negative. So there is a lower limit of that velocity. I hope you understand. At the topmost point, there is a lower limit. Did you guys understand this point? Okay, great. So guys, what is the lower limit? The lower limit will be, I'll write it down over here, for the string not to slack. Here is the condition, tension should be more than equal to 0. Equal to 0 will be the critical condition. So that equal will be critical condition. More than that is very good. Equal to 0 just becomes 0 is the just critical point, when it just becomes 0 and again it comes back. So that's the critical condition. So hence understand mv square by r minus mg should be 0 will be the critical condition. Okay, and therefore v square is equal to v square by r is equal to g. Therefore v is root rg. But this is not the final answer. This speed, please keep in mind, this speed is at the top, not at the bottom. Yes, this speed is at the top, and the question demands what should be the speed at the bottom to complete the vertical circular motion. So what will you do? Obviously energy conservation, guys. So use energy conservation and you'll get it. So assume that this is zero potential energy, okay, and if this is zero potential energy, let's write it down. Initial potential plus initial kinetic is final potential plus final kinetic. So look at this situation and look at that situation, conserve the energy, you will get the answer. Initial potential is 0, initial kinetic is half mu square. Final potential energy, think about it. Path does not matter. This ball has been taken here. How high was it taken? R plus R. So total is 2R. So it will be mg 2R plus final kinetic energy at the top, half mv square. Just like every time mass just gets cancelled out everywhere. So we'll have u square by 2 is equal to 2gr, okay, m gone, plus m again gone. V square, what is V square? It was rg but by 2, okay. So this will become 2 2s are 4, so 4gr plus rg divided by 2, but here you have u square by 2, this 2 and this 2 gets cancelled and you will get u as 4 plus 1 is 5, so root 5gr. That is the answer. So this is the minimum speed required for it to complete the vertical circular motion, else it won't do it. But this is, remember, only for a string, only for a string. So read the question. JEE has tricked many people many times. If it was a rod, if it was not a string, then you don't need to do all this circus. Yeah, this circus was not needed. You can just assume the speed to be 0 at the top, because the string, the rod won't become slack only. In that situation, you can try it out. The answer does not come out root 5gr, it comes out as root 4gr. Yes, Kanishka, chalo, I have taken your name. Come on, keep solving, keep participating. Got it, guys? So differentiate between string and rod. The answers are different. Okay, so let's go ahead. Look at this guy. Look at this guy. Don't you think this problem is very similar to the previous problem? If somebody asked with what speed should he start from the bottom so that he does not leave the contact on the top, isn't the problem same like the previous one, just that the different part is that instead of tension you have normal. It's one and the same thing. So you will find many problems which look identical in equations, just that instead of string you will have normal. That is, instead of tension you will have normal force. So this guy is doing it. This is an actual video, guys. He's moving with such a high speed. Yeah. What should be his speed at the topmost point? We just calculated it. What is the speed? Root GR. So at the topmost point, if he moves with root GR speed, he will not fall down, guys. He will not fall down. He's moving with such high speed that, you know, that think of it in a rotating frame. The centrifugal force is balancing the weight. That's what is happening. If you rotate at such a high speed, centrifugal force is balancing the weight. That's why he's not falling down. Yes. Same thing. Have you seen these kind of things in a city fair or a fair in a town or in some festival? Just one sec. A bike going upside down. Very similar. So guys, same question can be asked. What should be the speed at the top so that the bike does not lose contact? What will be the answer? Root GR at the top. But if the question says what should be the speed at the bottom, then just one sec. What would be the speed at the bottom? Then the answer for this will be root 5 GR. Same like the string, there is no difference at all. Keep this in mind. Don't have to by heart, sit and by heart every time. There is a question where a bucket is filled with water and it is rotated. Question is, what speed should I rotate it so the water does not come out? Again, the answer is same. At the bottom, the speed should be root 5 GR, so that by the time it goes up, the speed is root GR. Again, the water won't fall down. Same logic, same logic. All right. Jumbo Circus. Wow, interesting. Video games. So let's see how many of you can solve this question. I'm putting up a timer. Let's see how many of you get this. Look at this roller coaster ride. A roller coaster starts from here and it gains some velocity and it has to complete this loop without losing contact, and it's just resting on a track, and assume that the track is smooth. So the question is, what is this height, minimum height, so that when you leave it, it does not leave contact anywhere. Okay, so that's the question. Let's see how many of you get this. Starting the question in sometime, I'll give you 1 minute and 15 seconds. Come on. Anuradha, it is not 0 because instead of tension you have normal. So normal should be more than 0. So equation wise it will be very identical to the string problem. So that's why the speed should be root GR and not 0. Come on, come on. Welcome, Anuradha. That's the advantage of attending live classes, guys. You can ask your questions, you can participate with the crowd. When you watch it recorded, it's not so much fun. So always try to attend the live sessions because they are absolute fun. That's what all of you would have experienced. Come on, guys. Yanamdala, electrostatics is starting on, I believe, Wednesday or Thursday, all right? So it will be starting this week. I'll be starting with electrostatics on, I think, Thursday, if I'm not wrong. And the time is up. The time is up. So let's see, guys, how do we solve this problem? First of all, understand this problem. If you just hide this part, and if you look at this part, it's just like that bike problem or the pendulum problem, where instead of tension you have normal. That's it. So this guy's speed here should be root 5 GR so that he completes the vertical circle. So imagine when this guy is at the bottommost point, if his speed is root 5 GR, then when he reaches on the top, his speed will be root GR. Only then, understand, he will not lose contact. So the normal force will be more than equal to 0. If the speeds are more than or equal to root gr. So if the speed is more than or equal to root 5 gr here, only then it will be more than equal to root gr here, only then normal will be more than or equal to 0. So now the only part remaining is just looking at it in energy perspective. So what is there over here? Potential energy. Kinetic energy is 0. Over here, by the time he comes, he has kinetic energy, which is so his speed is root 5 gr. So just use potential energy got converted into kinetic energy. That's it. Use that, you'll get the answer. Potential energy is mgh. Kinetic energy is half mv square. That is, root will cancel out. Mass will go out just like usual. So gh is equal to 5 by 2 gr. Oh, 1 second. Even g will go out. So therefore, h will be equal to 5r by 2. So this is as good as saying h is 2.5r. Now this is a very interesting number. I don't know how many of you actually paid attention to this part, that this height, believe me, this height is 2r. But you should not start the roller coaster from here. If you start the roller coaster from here, this roller coaster will lose contact. You will lose your job as that engineer who designed that roller coaster. You have to start that roller coaster from here. This is 2.5 times of r, much higher. You can see this much extra is 0.5 r. Only then he will have some speed so that he does not lose contact. I hope this is clear. Very interesting problem. Did you guys understand it? Let me know. Come on guys, how is the Josh? Are you guys understanding? Are you guys enjoying? Are you guys relating it to real life scenarios? Are you guys seeing it? Why can't we use kinematic equations? Because acceleration is not constant. Remember, that's the most important condition for using kinematic equations. Very good guys, keep the chats full. Very good, very good. Excelente. Now, this is also a very interesting problem. Guys, discussing the motion of a pendulum, how the velocity, accelerations, etc. change. Yes guys, this is how velocity and accelerations change, and let's see why that happens. Okay, let's see why that happens. So imagine guys, if I show the pendulum at different places, okay, and it is left from an angle phi. So this angle over here is phi. Even this angle is phi. Okay. These 2 points are called as extreme points. This is extreme point 1 and this is extreme point 2. What is the meaning of extreme points? This is the point where the bob stops. Again goes there, stops, again comes back. It changes the direction. So over here, understand the velocity is 0. Here also the velocity is 0. But when it comes to the bottommost point, understand, it can be moving either this way or it can be moving the other way. Doesn't matter. Depends on where it is moving. This is the maximum speed with which it moves. Yes, this is the maximum speed over here at the bottommost point, because all the potential energy gets converted into kinetic energy, and then again that that kinetic gets converted into potential. So that's what keeps happening when it keeps swinging around like that. Now another interesting to note, at this point, if I ask you what are the forces acting on it, one will be tension, all right, then you will also have mg, and do not forget you will also have centripetal acceleration, correct, towards the center. What about tangential guys? Will there be any tangential acceleration? Come on, let me know. Is there any tangential acceleration at that point? Yes, you can use energy conservation. Why not? What do you think guys? I'm reading your chats on this side. What do you think? Will there be any tangential acceleration? Guys, NVD, think again. Which force is there in the horizontal direction? Is there any force in the horizontal direction? No, right? So how will there be any tangential acceleration? Guys, at this point, the tangential acceleration is 0. because there is only mg and there is tension, there is nothing in the horizontal direction. Yes, there is no tangential acceleration. Think about it. Okay, and if I had to write down the equation, it will look something like this: T minus mg is equal to mac. Therefore, T is equal to mg plus mac. And what will be AC? It will be V max square by L. This is how you can calculate the tension here. Guys, understand, in a pendulum, you know, or if you have sat in a ride which takes you like this and like this, you generally sit in a ship kind of a thing in amusement parks and it takes you like this. It's also a pendulum, or there are some rides called as just pendulum rides. So understand, this tension is the tension when you are at the bottommost point of that ride or the bottommost point of the pendulum. And think about it, the tension in the string is not only balancing mg, but it is supposed to be even higher than mg by this quantity. In fact, this is the maximum tension in the string. So if you were to design a pendulum, you will always look for this position, because if the string does not break at this position, then it will not break anywhere else, because this will be the highest tension in the string of all the available positions over here. Interesting. Which force is enabling it uncharted? There is no force, there is momentum. Remember this velocity, this momentum is helping it move here. That's all. And when it comes back, again the momentum in that direction takes it over there. So there is momentum. I hope uncharted, that is clear now. Now, if you go to these points, like here and here, you will have tension here. mg will be here. Guys, can you think and tell me what will be the centripetal acceleration here at this point, the extreme positions? What do you think will be the centripetal acceleration, guys? Hi Satish, come on, join in. Okay, join in crew. What do you think will be the centripetal acceleration there, guys? Come on, think. Will it be? Yes, very good, VSG. The centripetal acceleration will be 0. Why? Because V is 0. Remember, centripetal was V square by R? Correct. So that's why centripetal will be 0. But tangential will not be 0. That's the interesting part. The tangential acceleration will be there. And guess why? Because there is a component of mg in that direction. So here at this position, understand this angle is again phi. Okay, this angle is phi. Only over here, tension will be equal to mg cos theta. Only because AC is 0. Only because AC is 0. But in this direction, mg's component, which is mg, oh sorry, this is not theta, this is phi. Okay. And mg's sine phi will be m into at. That is what is important. So at the extreme positions, what is 0? Centripetal. What is there? Tangential. At the bottommost point, what is 0? Tangential. What is there? Centripetal. That's how this works. That's how it works. That's how this works. So it's a very interesting problem. Lot of questions come on this in JEE Advanced and Mains. Let me tell you in advance. Okay? Lot of questions come on this. And look at this. If somebody asks you now, what is the total acceleration here? Well, the total acceleration is in this direction. Think about it. This is the total acceleration because centripetal is 0. Over here, what is the total acceleration? Tangential is 0, so total acceleration is in this direction. Again, if somebody asks you what is the total acceleration here, well, it will be in this direction. Do you see how that acceleration vector is rotating? It goes like this and like this. That's how it moves. It rotates. Very interesting. Very good. So that explains that simulation, how that acceleration vector rotates itself. Notice at the end points, it's only having tangential at the end points, the extreme points, and at the bottommost point, it only has centripetal acceleration. That's what you can see in the simulation. And at the extreme points, look at that, the velocity becomes 0 and it becomes maximum when it is at the bottom, and again when it comes here, it becomes 0, the velocity. Very interesting thing. Now, how about going on curved tracks, just like I promised you? Very important formula that I'm going to give you guys. Thank you, Satish. If you study under JEE Enthuse, obviously it will be very easy. So, very important concept, guys. Remember, last lecture I told you that if you have a vehicle and if it is going on a curved path, the friction is the one which gives it the acceleration, the centripetal acceleration to turn along that curved path. But friction, the problem is it is an unreliable force, so you cannot depend on it because the road can become slippery, the tires can get worn out, so you need a more dependable force who can provide that acceleration. Who is a responsible force in the horizontal direction? Let me think. Well, friction is not dependable. There is only one force other than that, two forces other than that. One is gravity, but gravity acts down, so how can it give anything in this direction? So that means only normal is there which can give that acceleration. Yes, so when you tilt the road, look at this, the normal is going to act at an angle and a component of it will give you the acceleration. That's how it looks like. So when you tilt a road, believe me, even if the friction is not there, yes, even if the friction is not there, the car can go in that curved path because the normal is there. So this normal is enough to provide it acceleration, and then we get something called as the optimum speed. Do you know what is optimum speed? Optimum speed is that speed when friction acting is 0. Even if road is rough, and when friction acting is 0, there is very less wear and tear of the tires. So that is why it is called as optimum speed. And what is the formula? You can derive it very easily by taking n sine theta as m into AC, substitute AC as optimum speed square by radius, and you can also use n cos theta as mg. Look at that, n cos theta is mg, n sine theta is mac. Divide both of them, you will get tan theta is equal to v naught square by r by m is also there, by mg. So mm goes off, so you will get tan theta is equal to v naught square by rg. So therefore v naught is root of rg tan theta. This is the formula which you should remember. This is the formula. Okay, so keep this in mind, very important formula. Optimum speed is root rg tan theta. What is theta? Theta is called as the angle of banking. Remember that. Yes, very important formula. Okay, now the next part will be when you go with maximum speed. See, this is the previous one was optimum speed, like the ones which are written on the curved road. You would have seen those signs which are there. Those are the optimum speeds with which you should go. Maximum speed will be much higher than that. When you go with maximum speed, what happens is there will be one additional frictional force. Yes, frictional force will act on you because there is a tendency to slip outwards. Yes, there is a tendency to slip outwards. That's why friction will act and that will prevent you from slipping. In that situation, the maximum speed comes out to be root of rg tan, yes, theta plus alpha, where tan alpha is mu s. Please understand the difference between the two. This theta is angle of banking. This is a short formula. It is not there in many places. Your NCERT gives you one big formula which you always forget. This is the short formula I am giving you. This is angle of repose. If you have attended friction chapter sessions, you know what angle of repose is. They are two different things. And this is the maximum speed, correct. Rg tan theta plus alpha. Yes, friction will act downwards. So VSG we use tension because tension was not doing work, it was perpendicular to the displacement, that's why. I hope VSG that's clear. Okay, so guys, are you now remembering this formula? Okay, shall we do one question on this? How about doing a question on this? Let's do this. I hope you have written down what everything means. Let's do one question. Read this. A banked road in which traffic is moving at 54 kilometers per hour. The radius is so and so. What is the angle at which the road is banked? And what is the maximum speed of the traffic? Let's try this out. Let's try this out. A banked road which is designed means optimum. That's what you should understand. So it is optimum speed. So what is the optimum speed? 54 kilometers per hour. 54 kilometers per hour is 15 meters per second. Use the formula. V naught is root Rg tan theta, because they have asked what is the angle. So they have asked what is theta. So what is V naught? V naught is 15. Radius is 22.5 root 3. G is 10 into tan theta. Square both sides. 15 square is 225. 22.5 into 10 is again 225 root 3 tan theta. 225 goes. So tan theta will be 1 by root 3. So what will be theta, guys? It will be 30 degrees. So that is the angle at which the road is banked. That's the first part of the answer. Okay, I hope this is clear. Now the next part, what is the maximum speed? Now remember, for maximum speed, what is the formula? Root of Rg tan theta plus alpha. Now theta I just figured out. That's the angle at which the road is banked. But what is alpha, guys? What is alpha? Angle of repose. Is alpha given somewhere? Well, indirectly. From mu, think about it. Mu is actually tan alpha. Yes, mu is tan alpha. So can you guess what alpha is? Well, coincidentally, alpha is also 30 degrees. Okay, so I designed the problem in such a way that it comes out to be some nice values, that's all. So alpha is also 30 degrees. So maximum speed, guys, will be root of radius is 22.5 root 3, G 10, and this will be tan of 30 plus 30 degrees. So just do this. 22.5 into 10, how much is it? It is 225, and this will be root 3, and tan, this will be nothing but tan of how much? 60 degrees. So how much is tan of 60 degrees, guys? Tan 60 is root 3 again. So what will you get? 2, okay, my bad. So this will become 225 multiplied by 3, but under the root, so this will become 15 root 3 meters per second. That's the maximum speed. That's the maximum speed. So optimum speed was 54 kilometers per hour. You can convert this into kilometers per hour. That's not difficult. It's going to be much higher than that. Yes, root 675. Very good. I can see all the answers coming up. Very good. Very good. So that's how you do this problem. So believe me, this formula is very useful. If you know this formula, you won't have to remember that big formula which is given in NCERT. It becomes very easy. Yes, the limiting friction is acting, correct, VSGs. That's why it is not sliding. And if you calculate the speed, it comes out close to 93 kilometers per hour. That's much higher than 54. So 54 was optimum, 93 is maximum. That's how it works. Alright. So guys, remember, tomorrow is a very special class at 6:30. What is it on? Come on guys, what is it on? Write it in the chat box. Very good. Write it on the chat box, guys. Okay. IPL. Now, also remember, 12th standard students, I'm going to start electrostatics this week. 11th standard students, center of mass will be done day after tomorrow. Yes, the complete center of mass and its motion. I'm going to give you in one session all the formulas which are important, which will help you crack the JEE mains and advanced exam. All the important formulas, and we're going to solve problems on Wednesday. Yes, that is at 7 p.m. And Thursday, Friday, I'm going to conduct sessions on electrostatics. Guys, listen in, all the 11th, 12th dropper students, I am going to complete the entire thing before your exams, And a lot of you are asking, sir, what about units and dimensions, magnetism and all that, because that is also going to come for boards. Remember one thing, unless we complete the difficult topics, it is very difficult to actually do these kind of topics in the end. Once you are done with the difficult topics, it becomes very easy to do those simple topics, because now if I teach you semiconductors, you will forget it tomorrow. Yes, so that's why I'm going to conduct those sessions in the end. Units and dimensions, magnetism, semiconductors, transistors. I'm going to teach you everything. Don't worry, I'm going to tell you everything about all that, but that will be in the end, just before your board exams, some 3-4 weeks before that, so that you have enough time to revise it properly and it enters in your head and it stays fresh, or else you will forget it. Okay, so keep that in mind. Shreyas Sir is here for all of you. Very good. Okay, so do not forget to use the coupon code SHHPRO. Use it and you can get 50% discount. Offer is valid only till 11th of November. All right, and Telegram group link is there, so stay tuned guys. I'll be putting up all the extracts, all the homework problems, whatever is there on the Telegram group, so stay tuned on the Telegram group as well. Thank you Jumna, thank you VSG, thank you Poetry, thank you Uncharted. Yes Jumna, very good, thank you Aarti. And guys, please like the video, go ahead and subscribe. If you're a new user, go ahead, subscribe. All right, chalo, bye bye guys. I hope you had an amazing time. Take care, stay safe, stay at home. This was Shreyas here signing off right now. Bye bye.